Hello friends, welcome to yet another class of Vidhai. This video is brought to you by the Exams Possible team of Vidhai. Exams Vidhai is non-profit initiative by the students of IIITDM Kancheepuram to give free coaching and resources to students preparing for national level competitive exams like NTSE and NMMS. In today's discussion, we will be covering the following topics: Introduction to Figure Partition, different types of questions asked. We will also be solving various practice problems. So, let's start. The problems of figure partition are based on counting the number of figures generated due to partition lines. It is one of the most important topic in math. Scoring good in this topic gives you a competitive advantage in entrance exams. To score well, you have to either count the number of figures carefully, which is time consuming, or try and remember different formulas based on memory. Yes, I will try and explain various types of questions asked in exams using example problems. Yes, let's do it. First type, find the number of straight lines in the figure. Let's try and solve. Clearly, there are three straight lines, namely AE, LF, and KG. There are five vertical lines, AK, BJ, CI, DH, and EG. There are six slanting lines, that is AG, EK, LC, CF, FI, and IL. Thus, there are 14 straight lines in the figure. Just add them all. This was a very simple question. Yes. The next question. Find the total number of squares embedded inside another square. This is a common type of question that is asked. To solve this question, you have to use this formula. That is, if the square is divided into n parts on each side, then the total number of squares formed is given by n into n plus 1 into 2n plus 1 by 6. Yes, we can use this formula directly to get the answer. Over here, n is equal to 5, and when we substitute n equal to 5 in the given formula, we get the answer as 55. That is, you have total 55 squares that are embedded inside the larger square. Yes. On to the next question. Counting triangles within another triangle having bisects with vertex and horizontal lines. Yes, let's see. Formula. To solve this question, you have to use this formula. If the number of vertical parts is n and horizontal parts is m, then possible triangles is n into m into n plus 1 by 2. Yes. Let's substitute. In the given figure, the number of horizontal parts m is 3 and the number of vertical parts n is 4. Substituting in the formula, we get the total number of triangles as 30. Yes. Next question. Find the total number of parallelograms inside another parallelogram. This is similar to the one question you have solved before regarding square. Yes. Formula. Total number of parallelogram inside another parallelogram of side n into m is equal to n into n plus 1 by 2 into m into m plus 1 by 2. N and M here are the total number of parts in which the parallelogram is divided into, horizontally and vertically. Over in this figure, N is equal to 2 and M is equal to 3. Substituting them in the formula, we get total of 18 parallelograms that are embedded inside this larger parallelogram. Yes. Let's see the next type. Counting total number of rectangles embedded in a square. So as you can see, this is a chessboard. Let's look at the formula. Let n be the total number of parts in which the side of the square is divided. Then total number of rectangles is equal to n into n plus 1 by 2 whole square. Yes. As we know, the square board is 8 into 8. So in this figure, n will be equal to 8. And substituting n as 8 in the given formula, we get the total number of rectangles as 1296. You can even check this with the calculator. Yes. Let's solve a practice problem. Find the total number of triangles embedded inside another triangle. This is similar to the question we have solved before for square and parallelogram. I would ask you to pause the video for 10 minutes and try and solve this question on your own. We will now proceed with the solution. Formula: total number of triangles inside another triangle whose side is divided into n parts is equal to n into n plus 2 into 2n plus 1 by 8. Yes. Over here, n is equal to 4. We get the total number of triangles as 27. So, looking at the questions and solutions, you might all think that this is a formula-oriented chapter. But that's not exactly the case. You can even solve it using logic, but you have to practice a lot. Yes, solving questions of this type improves your mental thinking, and also it gives you a competitive exam in the exam. Thanks for attending the class. Please check the description below for extra questions and lecture notes for each chapter. If you have liked the video, please consider to like, share and subscribe. Thank you.